So here we are now with Opus 5 set up as the default model, and I am gonna paste in my command and let it go at it. And we'll check in with it as soon as it's done. All right, so let's see what Opus decided to build here. So it triggered a workflow with 11 agents across 5 phases. So that's already much more intense than what Sonnet decided to do. And here's the design that it decided on. So it's doing a real, not faked. That's good. uh, all right. Pitch channel 0 gets reprogrammed at scheduling it from BIOS's mode 3 and mode 2 with the same divisor. Okay, the same 18.2 hertz tick, but the readable counter becomes a clean 0 to 64K down count instead of mode 3's. Okay, which can't be read unambiguously. All right, I don't know. This is doesn't make a lot of sense to me, unfortunately, because I don't know all the internal workings of the IBM XT's architecture. I know how to program chips like in assembly, but the x86 assembly is something that is beyond what I could do, and to build something useful anyway. Well, I wouldn't say that because I could build some basic things with assembly, but nothing like this, obviously. And this is all being written, by the way, with assembly. So let's see here. Then it constructs an absolute timestamp and charges the whole interval. So 0.8 microseconds. All right. Let's see what it does with that. Idle versus busy. The UI's task manager never sleeps, so a naive meter reads 100% forever. Races the top of its poll loop and drops it, and the instant real work starts. Okay, so the keyboard event poll is charged idle, and menus drag clicks are charged busy. Okay, that's good. And the window. So one new bar plus a 2-column white gap per update, oscilloscope style, so an XT isn't asked to redraw 288 columns twice a second, with a live percentage, 2 memory bars, total RAM, with the 192 reserved shown as dither. And okay, so this one is going to show some reserve space. That's nice. And the 64K kernel segment broken into kernel, resident package free. All right, so it looks like we have a 64K kernel limit, and we're at 22 kilobytes more or less. When you load Minesweeper, okay, and 1 row per task with name, state, and CPU share with the bar. Okay, cool. And the QEMU, okay, so it's gonna run QEMU to take some screenshots and verify things. All right, so right now, if I click here, I can see that it decided to do some contracts and implementation for the scheduler, the task manager, the wiring, and documentation. It did the build, and now it's doing the verification, and then it's gonna do any fixes after it verifies. So again, much more. This is Opus, so it's much more organized in how it runs the workflows, and it's probably gonna come up with something useful, very useful. But we're still gonna try Fable afterwards, and then I may even consider using Codex with ChatGPT with its latest models and see how that performs. All right, let's see. Let's wait here. It's probably going to take another 20 minutes or 10 minutes, and then we'll check back in. All right, so here it is. So it finished up with Opus, and it went ahead and verified its work. It decided to do its own verification at the end. It says, let me verify this myself, rather than trust the reports. So it didn't trust its own sub-agents. But it did find a bug, and it found a cosmetic flaw, and it fixed it. So let's go ahead and try this right now. I'm gonna go ahead and go to a new tab again, and you can see here that this built out a lot more files than the other ones. And I am going to make XT. and it should load the emulator. All right, so this is 86 box, okay. All right, this memory test. I gotta see if I can disable that thing, because come on, do I really have to run this memory test with a simulated machine? It does make it look very authentic, I have to admit, but all right. Job is loading. I think I'm gonna open source this when I change the name to something better. So if you recommend a good name, I'll consider it. All right. So here we go. So we got again, we got the clock, we got everything running. We got this B here, which has mimes and not mimes, Minesweeper. And we have go to special and we go to task manager. Ah, check it out. That's even more impressive. So we got this right here. We got the system that it takes up 0 CPU. You got clock. It's in sleeping. Oh, I see. So let me see. It's gonna, the clock is, I wonder if the clock skews. And I don't know what clock this is following. It looks more like a timer than a clock. All right, there's a lot of flashing going on. I wonder if that's something I'm gonna be able to like fix, given the way that this works. Maybe that's why they didn't do preemptive multitasking in the early Mac days, because it's causing too much flashing, and they said, oh, we can't ship that to people. So let's see here. We got CPU usage, which is expected. Then we got RAM, we have 256K, and we have 192K used. That's a lot more than I expected. So this, obviously we're using a lot of more RAM than I expected here. Free 64K. The kernel is 24K, and free is 40K. So I wonder if I close some of this stuff, what happens? If I close the bounds, so I only have 64K of memory to use, and then this is the actual, so 192K is reserved. I wonder why that is. Okay. And then if I close the clock, and if I close the notepad, okay, there's still a lot of flashing, but given that this is an XT machine, it's, oh, look at this. They're still running as part of the kernel. I don't think I want that. Well, the clock is running, the bounce is running. Why is that? Is it because they're minimized, they're not closed? All right, so this is giving me some insight into how this system is working, because I think I want to make sure that the applications close out. And also, I didn't ask it for any color, so this is okay. I think I'm gonna leave it like this because I do want to probably support monochrome displays in the XT machines when I start trying this out. All right, so there's one last model on the Anthropic side that I want to try, and let's go ahead and do that right now. I expect it to be very similar, if not exactly the same as this one. So, but who knows? Maybe it actually might do something different. So we'll see. Let me go ahead and do that.